or there is any echo?
Yeah, you are audible now.
Okay, cool. If you have any question, you can just unmute yourself and ask, or you can also like just send that thing in a chat. Okay, both will work. So object of today class, today we will discuss the routing and ACLs. Just hold on, yeah. So today first we did discuss the routing and the ACL. Okay, so this is our ASA firewall. So that firewall supports the routing protocols. Okay, so it supports the static routing. It also supports the dynamic routing, which includes your dynamic routing protocol like RIP, EIGRP, OSPF, and BGP. Okay, so these are the main routing protocol. So it supports these protocols as well. So what happens? Sometime in your inside network, let's suppose you are having more devices, right? Let's suppose this is your firewall. Here you are having core switch. Okay, this is a L3 switch. After that, you are having some L2 switches over there. Okay, like this is a one switch, this is another switch, like switch 1, 2, 3, and 4. And behind these switches, all the users is available. Okay, all the users and server. So what happens? That firewall have a direct connectivity between this interface with this switch, right? So what happens? We need to define the routes. If we are using a static route, then we just define the static routes, so our firewall also can able to reach to these guys, right? Because they are maybe in different subnets. Okay, if you know, like if we are using this subnet 192.168.1.0/24, it is having only 254 IP addresses. Okay, so let's suppose we are having around 1000 employee in our network. Okay, that time we need more subnets, right? So the thing is, in that cases we generally configure the static routing. And also just remember one thing, this is the firewall. Okay, so that firewall only designed for doing the ACLs and NAT. Okay, it's not like router, because generally we use router for doing that routing and all. Okay, so what happens, it supports these routing protocol as well, but what happens, we cannot like configure all the features of RIP, all the features of EIGRP in firewall. Okay, it is like limited. We can run the basic EIGRP only. So you just remember that point. By using firewalls, we generally do the ACLs and NAT. In AC, you can also say like rules. ACL also known as rules. Okay. So now you got the idea what is the routing, why we use routing, right? To basically, generally what happens sometimes. Generally, let me tell you, draw one diagram. Okay. Let me open Notepad first. I will include some production level diagrams. Okay. Like that kind of scenarios we are having in production generally. So in production generally, this is the ISP. So this is ISP1. Okay. This is the ISP2. And this is the ISP3. So generally, job of ISP is to provide the internet connection to the organization. Okay. After what happens, this is your company firewall. Okay. That firewall have a connectivity with all these three ISPs. That firewall always have a connectivity with the L3 switch or router. Most of the time you will see L3 switch, which is a Nexus switches. Okay, and that switch have a connectivity with L2 switches, like switch 1. This is switch 1. Okay, switch 2, switch 3, like this. Okay, maybe here you are having 100 of switches. So, and always this is, and that firewall have a connectivity like this. Okay, after that what happens, like we have connected the firewall interface like giga 0/0, and that interface also we define as an inside interface, right? And what happens, we also take one more interface, okay, like giga 0/1, and that interface we use as a DMZ. After that, like in this place, we are having some DMG switches, okay. So this is our DMZ network. So generally we are having that kind of scenario because that Nexus switches are very costly. It's like, these are like 3 crore and all in Indian rupees. So these are the very high cost switches. That's why we usually put one switch or maybe two switch. It depends on the network and all. Okay. You can also use like basic switches, like there is a like Catalyst 6500 series, and there is a some ASR series routers. Okay, CSR series router. We can also use these routers. I'm just telling you, most of the time you are having these Nexus switches over there. And in DMZ, you generally having your servers, right? What happens, maybe if you are having multiple switches over there, right? So that switch is also having a different VLANs. Okay. And also having like this one having an IP address in 10.1.1.0 range. This is having 10.2.2.0/24 range. Okay, this one have 10.3.3.0/24, like this. Okay, and maybe in DMZ you are having like this 172.16.1.0/24, after that 2.0/24, like this to reach. So the thing is, what happens, our firewall is not able to reach these guys, so we need to define the routing over there. Okay, so we can run any routing protocol like ESGRP, RIP, OSP, BGP, and most of the time you will see people always go for the static routing only. Okay, because static routing is very easy and having more control. Okay, any doubt with this? So generally they will ask like what kind of scenarios, or maybe if they ask that scenario based question, they include that kind of diagrams and all. Okay, if you are aware of these things, and also let me complete these things. So what happens, we are having here 3 ISPs, right? So let's suppose this is our primary ISP, this is our secondary ISP, and this is third one ISP. Means if that ISP goes down, we are having secondary ISP for traffic forwarding. If that ISP also goes down, then we are having third one. Okay, so generally what happens, we configure the load balancing over there. Okay, there is a concept ECMP, equal cost multipathing. We use that concept. So the thing is, firewall sends the traffic on this interface. Like if we define like 30% traffic go via this, 30% via this, and 40% via this. Okay, so it sends the traffic like this only towards the ISP. If anyone goes down, then all the traffic basically, if like that third one goes down, then that traffic shifted on a primary or secondary. Okay, after the two just share the load. Okay. Any doubt in this diagram? Anyone? Man. Okay, then let me remove this one. Let me go through with the slide. Okay, so these are the some routing features on ASA. We are having static routing, we are having dynamic routing, which is RIP, OSPF, ESGRP. Authentication routing protocols means, let's suppose we are having ASA here, right? And we are having one router over there. When we configure these routing protocols on these firewalls, right, these devices, so what happens, we can also define the keys like Cisco here and Cisco here. So that key, if they are having the like same key, then only they will authenticate to each other. Means they are just communicating to the right pair or not. For identifying that thing, they use that kind of things, authentication. Like when you do the any banking transaction, you have to log in into your bank, right? That time you put your username, password, and OTP, right? So it's a like similar thing. That time you have you just authenticate over there. So they are also like authenticated with each other. And this where we are also having route tracking. Route tracking means, you know, this is your ASA, right? Let me draw this one. This is your ASA firewall. It is having, this is ISP1, this is ISP2, and this is ISP3. Okay, these are the ISP routers. From there you got the connection. So what happens? You always define the static route. The default route was these ISPs. Okay. So what happened? You are having that static route in your routing table. If this ISP goes down, how your firewall know that ISP is no longer available? Okay. So the thing is, for that we need a route tracking. We generally just track the IP, this interface IP. So if there is any like, if that interface goes down or there is any problem with the ISP, that time our traffic shifted into the other ISP, second one. Okay, so we use that concept, route tracking. And also one more thing, we can also use router. Maybe this ISP have another router, right? Maybe this one having another router and this one having also another router. Let's suppose in this point everything is fine. Maybe this router goes down. That time also we lose the connectivity with the internet, right? Because let's suppose there is a somewhere internet. Okay. So the thing is, generally for that kind of issues we can also resolve by route tracking only. It is also known as a IP SLA. Okay. Service level agreement. In router generally they will call IP SLA. Okay. Any doubt with these 4 points here? Okay, then so the thing is, now I will tell you how we can add the routes and all. Okay. Adding a static route in ASA. This is the command. Okay. Route. After that we need to define the name, right? When we configure the IP address on any interface of ASA, we need to define this name and value, right? After that, IP address, mask, and gateway. Okay, this is a static route. So if we want to define the default route, generally we give route. Always we take here outside. Okay. So the 000, 000, and the next hook means gateway. So let's suppose this is our ASA. It is have a connectivity with ISP1, and this is L3 switch. Okay. And here we are having some networks like 10.1.1.0/24, 10.2.2.0/24, and 10.3.3.0/24. And we are having here 192.168.1.0/30. So we are having 1 here and 2 here. Okay. Now on ASA, if I want to define the static route for this network, so what I'll do, I'll use this command, route inside. Let's suppose this is my inside interface, this one. Okay, route inside. After that, I'll define the subnet 10.1.1.0, then mask 255.255.255.0. After that, the gateway. So gateway is this IP address. Okay, the other end IP address, which is 192.168.1.2. Like this we will define. If if we want to add another one, we use same. Here we use 10.2.2.0/24, 10.20. After this one same, this one also same. Okay, let's suppose I want to go to the bus internet, right? Here we are having internet, right? That ISP having connectivity with the internet. So what happen in that case? We always put the default route. So this is the command for putting this route outside. We define the 0.0.0.0.0, 0.0.0.0.0, and what is the IP address? We put the IP address of our ISP here, the next hop, which is, in our case, I'm using, let's suppose here we are having this range 200.1.1.0/30. So we are having 1 here and 2 here. Okay, so we use this one 200.1.1.2, this IP address. Okay, this is the particular how we will write the commands on ASA to configure the routes and all. Because we will see the practical of static routing. Okay, I will tell you the command for dynamic routing as well, but there's no mean to, because I have not seen much. There's a routing protocols, okay, but people always go for that is static routing only in firewall. Okay, so let me open my firewall. This is the same firewall. Okay, we have already configured our interfaces. If you can see by running this command, so interface IP brief. We are having interfaces configured already, right? We also have configured our name. So you can run this show name. So we can see the name value. Okay. Now what I'll do, I'll just open this router, which is my inside router. Okay, I'll just go this one. So now you will see how we can configure the routing like that, IP address on router and also default route on router. Okay. I'll give the name hostname, which is inside interface F0/0. I'm just configuring the IP address on fast Ethernet 0/0, no sat, and I'll configure the IP, which is 10.1.1.100, 255.255.255.0. We need to configure the IP address on same subnet. Okay, because we are having IP address on this internet, which is 10.1.1.250/24, right? So we also use the any IP address on this range only. So I'm using here 10.1.1.100. Okay. Now I also need to, let me also show you one thing over there. So if I go there, if I run the ping 10.1.1.250, I'm able to reach my firewall or not. I am able to ping my firewall interface, means everything is fine, our interface is working properly. Now if I want to ping this one, public IP address like 8.8.8, this is a Google IP address, okay? I'm not able to ping because this guy is not having any route on the routing table for this network, right? That's why it is not able to send any traffic. Okay, if I'll check the routing table, we run this console IP route. See, I'm not having any routes. So generally we configure the default route. Okay, so this is the command to add the default route on router 10.1.1.250. This is the next hop, right? 250, because that we are adding the route on this device, right? So the next hop always the other device IP address. Okay, so we have done with the routing now. we have added this default route. Okay, so route, so IP route. Now it is having the route over there. So this is the way how we can add the default route and the that thing and the IP address on router. Same thing I will do with this guy because this is our DMZ. I will give you the assignment like this only. Okay, so you have to follow the same thing. If you are able to complete that assignment, that time you are okay with the ASA. Like that time you got the basic idea of ASA. If you want to learn, you need to do lots of labs on that. Okay. So here I use this one 10.2.2.100 and 255.255.255.0. If I try to ping my ASA interface 10.2.2.250, I will to ping, right? Now I will also need a default route over there. So I use the same route 0.0.0.0, 0.0.0.0 and 10.2.2.250 because we are having the IP address on ASA, this one. And then this command write memory means I'm just saving my changes. Okay. Same thing, let me run over there as well, right? Memory. You can also just run that command like WRMEM like this. Okay, it will take. Now let me go into my firewall. If I see my routing table, so now I am having one default route, right? Which is pointing towards outside. So learn route. Okay, this is the way to configure the route and all. Okay, if I want to add any static route, let's suppose I'm having one network over there behind this particular router. Like I am having here 10.1.2.0/24 and 10.1.3.0/24, these two networks. Okay, so I need to add the default route for them. How I can add? So let me also introduce these networks, okay, on this particular router, which is the inside router. Okay, so how I can introduce? I'll just go there. I'll just create a loopback interfaces, IP address 10.1.2.100 255.255.255.0. Let me also create one more loopback in there, which is one where I'll configure the IP address, which is in this range 10.1.3.100. So I have configured these networks. If I'll try to ping these networks from my ASA, ping 10.1.2.100. I'm not able to ping, right? Because I'm not having the route for this network. I can only be able to ping this one 10.1.1.100. It is working because it is directly connected. Okay. So what I'll do, I'll just go to in my firewall. I'll just add the route. After I need to define my name, which is inside, right? And after that, I'll give my subnet 10.1.2.0. After that, I need to also define my subnet mask, which is 255.255.0, and the next one, which is 10.1.1.100. This time I'll run that ping. I can ping. Yeah, see, ping is working now. If I try for 3.100, I am not able to ping because I have not added that route. As soon as I add the route, I am able to reach. So that is the like way how we configure the routing and all. Okay. So what I'll do, I'll just add one more route inside. I'll just change the value here, which is 3.0 now. If I'll ping again, this one, ping is working, right? So this is the way how we can configure the static routing on the firewall. Anyone have any question on that? Guys, if you have any doubt, just ask me. Okay. So are we good to go? Okay, then just respond, man, at least. Let me go into the next protocol. Okay, cool. Thank you, Dibya. So this is the way for static routing. Okay, we are also having these dynamic routing. Okay, RIP, EIGRP, and OSPF. So this is the way. If we want to configure the routing, the RIP protocol, we can configure router RIP. After version 2, we need to define the network and we need to run this no auto summary. We need to only run these 3 commands over there to configure that particular routing protocol. Like for EIGRP, for configuring EIGRP, we need to run these command router EIGRP. After we need to define the autonomous system here, network, and the subnet mask. And we at the end we run the no auto summary. Same with the OSPM. Okay, so let me show you these commands as well. So what I'll do, I'll also introduce the 2 networks over there in my DMC. So these are the networks. Like I'm having here 10.2.2.250 IP, and I'm having here 10.2.2.100, right? Let's suppose I'm having 3 networks over there, which is 10.2.3.0/24, 10.2.4.0/24, and 10.2.5.0/24. Let's suppose I'm having these networks as well. Okay. So I will configure the routing protocol for them. Okay, so in this segment, okay, we will run the dynamic routing protocol, and in this section we are running the static routing. Okay, so what I'll do, let me open my DMZ router and let me introduce. So to introduce any network, you just create the logical interface, which is loopback interfaces. 10.2.3.100 255.255.255.0. You can also add one more, which is and 4.100. Here I am having 5.100. If I need to see my interfaces, so I'll first come back into this mode, okay, that privilege mode. After that, here I run it. So IP interface brief. This is the command, okay, to see the IP address on router. Because if you run that command in ASA, we run that command. So interface IP brief, okay. So interface is first, then IP in case of ASA. If we want to see the interface on router, we run so IP, then interface brief, okay. So we have these interfaces, right? Let me also see my firewall. So now you will see how we can configure the routing protocols as well on firewall. Let me just disable these things for a couple of minutes. This is the command router rip. We need to define the network, just 10.2.3.0, 10.2.4.0 and 5.0, and after that version 2 and no auto something. Only you need to run these commands. Okay, here we have added 3 networks, right? Because we are having 3 networks in our inside, this one, this one, this one, right? That's why I have added these 3 networks. What I'll do, I have run my routing protocol on ASA firewall, right? If I'll check my routing table, so route. See, I'm not getting any route from rep because I have only run that routing protocol on one device, right? I also need to run that the same routing protocol on the other device, means other end. So I will run that same thing. So if you want to run that routing protocol on router, you need to run this commands: IP router rip. No, this is the command router rip. You need to define version, which is 2. You need to define the network, which is 10.2.2.0. I have done one mistake. Okay, I will explain you. 10.2.3.0 and 10.2.4.0 and 5.0. So run router rip. Yeah, it is taking. Okay, no worries. See, we have, it takes that 10.1.10.0.0.0. Okay, it is not taking which we have run. If we can check these thing by seeing the history. So history. So we can run that command, so history. Okay, that command gives you what you have run. So generally we have run these commands, right? But it is taking 10.0.0 because the thing is, by default it will take the /8 because you know it's a like class A addresses, right? That's why. So if this time you will see that your routing protocol. So if you run that, so IP route, now you are getting routes from RIP. R means RIP. Okay, here you will see R. So you are getting this network, you are getting this network, you are getting this net, these 3 networks from RIP. Okay. And also one more thing, only here you need to define these 4 networks because they are connected with this router, right? DMZ router. You see a diagram. You only need to call this network 10.2.2.0 on ASA. Okay, you don't need to run these other network as well. I have done that mistake. Okay, so when you configure, you run this 10.2.2.0/24. That's it. Nothing else, because it is taking by default /8 only. That's why I am able to reach. So if I can also now ping these 10.2.3.100. So I am able to ping. So that is the way how we can configure the routing protocol. Okay. That if you want to delete that configuration regarding RIP, so you just go there. You can run this one. So run router RIP. You just select this one. Okay. Press the no here and just paste it. When you select, so basically it is copied now. Okay. Now you only need to press the right key. Okay. So it will copy it, or you can just also just put the no and you can type this whole command. Okay. So now I have removed the RIP. I'll go there in in my router. I also need to remove from here. So no router, I run this same command over there as well. So I have removed. If you see, so route is also removed now. Okay. So that is the way how you can configure the routing on a firewall. Generally, you will see the EIGRP configuration or OSP configuration on firewall if you see anywhere. Okay. Now let me also configure the EIGRP very quickly. Router EIGRP. Here we need to define the AS number, autonomous system. So I have defined here 100. That autonomous system number must be same on both the peers. Okay. After that, I can define the network directory, network 10.2.2.0. After that, I will define the subnet mask, which is 255.255.255.0. Okay, I only need to define that network only on this one, and after that I will run this one. So no auto summary. Okay, only I need to run these commands on there because we are having that connected network over there. Okay. 10.2. So I only need to advertise this network on this EHRP processor on firewall, because here I'm having 4 network, right? One is this one and other 3 is here. So I need to put the 4 network over there in my EHRP process when I run that EHRP on this router. So I'll just run this router EHRP autonomous system number same, which is 100, network which is 10.2.2.0. So the thing is, what happens in firewall, generally we have run this subnet mask. Okay. In router we need to run the wildcard mask. Okay. So you can search what is the difference between wildcard mask and subnet. It's like just opposite to other one. Okay. Like /24, I only need to write this one 0.0.255 like this. This is the wildcard mask. Okay. I also need for 3 network, and I will call the 4th one, and I will call the 5th one. I have called these networks. Now if I'll see my routing table over there, so route, I'm getting these networks, right? And D means ESRP. You can see like D here is ESRP, R for ref. Okay, so that is the way. We also need, I have not run the no auto summary, right? We also need to run the no auto summary command. Just forget to run. Okay, so you have to run over there. That's the way how we can configure the EIGRP as well on the firewall. So let me go into this here. Okay, so you can run the OSP is also like similar. Okay, so I'm not going to explain OSPF. It's like similar, because you always go with the static only. That is the recommended one. These are the authentication. So generally we don't configure these things. Okay, in production. Like if we are configuring that routing between ASA and the routers, if we are using the router, we are configuring that routing between routers or between firewalls, then in that case only we will run these things. So this is a static route tracking, means generally we use for track the ISP if there is any failure happens with the ISP. Okay, that's it. Yeah, so we are done with our routing now. Now let me tell you one more thing. So anyone have doubt with the routing? Anybody? Okay, so generally what happens to configure a device, we need to first configure the IP addresses. Okay, that is the first requirement to configure the firewall. After that, we will configure the routing. Okay, that is the second point. Third one is NAT, and fourth one is ACLs. So today, let me complete the ACLs as well. Okay, so we will complete the theoretical part of ACLs, and tomorrow I will complete the NAT and NAT. So I'll just add the configuration of NAT and the configuration of that ACLs as well. Okay, so today we will complete the theory, what kind of ACLs we are having and all, and also I will little bit touch the NAT. Okay, so also let me tell you one more thing. If I'm talking about NAT is a like network address translation. Anyone have any idea about NAT? Okay, so what happens generally, there is a like public IP addresses and private IP address. Okay, so what happens, that private IP address is used by everyone, right? Anyone can use this private IP address, but the public IP address is limited, right? And only the guy who is authorized to use that public IP, they can use. So for that, generally they will purchase these IP addresses from the ISP. Okay, because INA, right? They have defined these things, INA. Okay, these things. So that generally what happens, INA have divided these things between like lots of like according to like Asia Pacific, US Pacific. Okay, so they also have divided these things with the some regional IP directories. Okay, so according to that, what happens, so generally every organization purchase one public IP or two public IP or maybe three, because these IP addresses are also like costly. Okay, so what happens, these private IP address also not able, we cannot send the traffic by using private IP address into the internet. Okay, that private IP address is not routable on the internet. Okay, so what happens, we to basically overcome this kind of issues, we usually use the NAT. Okay, so what happens in NAT, it will change that private IP into the public IP. Means when, let's suppose this user sends the traffic towards the internet, like this guy. Okay, so this is the source currently. This is the source IP of this guy, right? When that traffic reaches to the firewall, in this firewall we have configured NAT, right? So what happens, that IP address will change, okay, into this IP address, like any public IP, like 200.1.1. We are having here 101, then on 1, like this. So this source translate onto this one. So let me also draw a proper packet for this. So let's suppose I'm having IP address which is 200.1.1.1 on this interface, and 200.1.1.1 and 2 on this interface. Okay, and let's suppose here we are having Facebook server, and Facebook IP address is 139.1.1.10. I'm just taking that example only. Okay, so this is the public IP, this is the public IP, and this guy having this IP address 10.1.1.100 means this is the private IP. Okay, let's suppose this guy initiate a connection towards the Facebook. Okay, so what happens, the packet format is like this. Source is 10.1.1.100. This is the source IP, which is a private IP. Okay, and destination is this one, 139.1.1.100. 1.1.10, sorry. Okay, this is the destination IP. D means destination IP. Okay, this is the source IP. And let's suppose it is sending the HTTP traffic. And here it is having some data, means actual traffic. Okay, so when this packet reaches this firewall, this ASA firewall, so what happens, the thing is, after translation, that packet become like this. 200.1.1.1. This become the source IP now, and the destination is same, 139.1.1.10. Port is 80 and the data. Okay, so this is the packet before NAT. This is the packet after NAT. Okay, after NAT or after translation. This is the before NAT. Anyone have any doubt with this? That is the working of NAT. It just translate the IP into another IP. Means this is the private IP and this is the public one, right? Public IP. So it translated this private IP into the public IP. Okay. So what happens here? So this is the case of dynamic NAT. Because in NAT we are also having some categories. So I have explained you that this is a case of dynamic NAT. Let me first. So everyone is okay with that, right? The translation and all. If you have doubt, just ask with this. It's important. They will ask definitely that question regarding NAT on interview. NAT, PAT, dynamic NAT, static NAT. Okay, like this. So now let me explain you in NAT. Basically, we are having first one is a dynamic NAT. This is also a one-to-one NAT. I will explain what is one-to-one. After that, we are having PAT. After we have PAT, it is a one-to-many. Okay, so what happens in dynamic NAT? It's a one-to-one. So means only one private IP, like this is the private IP. We can only transfer one private IP into the public IP. This is a case of one-to-one, means only one user can access the internet at one time only. Right, so if we are having around 1,000 users, that time we need 1,000 public IP address to provide the proper connectivity to these guys. This is the dynamic NAT. But like if we are going to purchase 1,000 IP at that public IP, it will cost huge. Okay. So what happens to avoid these problems? People come with a PAT. It's a lie. So that's why dynamic NAT is a one-to-one. In PAT, what happens? They basically translate it on the basis of PAT ports. Okay, PAT is also known as a port address translation. And you know, like ports are belonging from 0 to 65535. And you know, like 0 to 1023. These are the well-known ports, right? So the thing is, our ASA can basically, if we purchase one public IP, right? We are having if this public IP, then what happens in case of PAT? It can provide the internet connectivity to 64,000 users, or it can basically do the connectivity for 60,000 sessions. Usually, session is the good term for that. So if we are having around 10,000 users or 1,000 users, we only need a one public IP. Let's suppose here we are having around 1 lakh users. That time what? That time we need a two public IP, right? Because by using one public IP, only this much session we can send, right? Okay. So if we are having that much users or like that much session is created, generally go with the sessions only here. Okay. If 1 million session is created simultaneously at the same time through your organization, in that case you need a two IP addresses. Okay. Two public IP. Like it depends on like this number only. Okay, so now let me draw a packet for PAT, how the PAT will work. Okay, so let's suppose I am just taking the same server, Facebook server. This is the IP address 139.1.1.10 and it is hosting the web service, means HTTP service on port 80. Okay, so when this guy 10.1.1.100 and we are having here public IP which is 200.1.1.1 and here we are having 10.1.2 on ISPN. Okay, so when this guy send the traffic towards the Facebook, so this is the format for that packet 10.1.1.100. This is the source IP and 139.1.1.10. This is the destination IP. So the thing is, when this guy send any traffic towards the Facebook, it also choose the ports, okay, between 102.4.2.6.4.6.5.5.3.5 in this range. Okay, so it choose the random port. So let me take this one 1, 2, 3, 4. Okay, let's suppose, so this is the source port and destination port is 80 because it is running the web service on port number 80. Okay, this is the destination port, it's not IP, it's a port only. Okay, and after it we are having here data. So what happens when this data reaches till the firewall? So now firewall do the PAT. So he just do the PAT like this. He just exchange this IP address. He just transfer this IP into 200.1.1.1, 139.1.1.10. After that, he basically use this particular port here. Okay, 1, 2, 3, 4, and the 80, and here is data. So this is the source IP. This is the destination IP. This is the source port and this is the destination port, like this. Let's suppose at the same time we are also having here the Google server. Okay, and IP address this Google server is 8.8.8.8 and let's suppose it is running the DNS service on port number 53, which is UDP. Okay, so what happens, that same guy also sends that same connection towards this guy as well at the same time. So for that, packet format is this one. Let me choose the black color now. Like IP is 10.1.1.100, 139.1.1.10. Okay, not 10, sorry, I need to remove this one. This is the 8.8.8. Okay, this is also public IP. This is the source IP. This is the destination IP. In this time, basically it use the another port. Okay, like it can use 5231, any port. Okay, and this is the 53, means this port is fixed because it is running the service on this port. So this is the destination port and this is the source port, and here it is having some data. So when this data reaches to the firewall, the packet become like this 10 dot. The 10 dot will be changed into 200.1.1.1, 8.8.8.8. It uses 5231. 31, okay, and the 53, like this. So this becomes source IP, this becomes destination IP, this becomes source port, and this is destination port. And here we are having data like this. So it is doing the translation like this. Now let me take one better example over there. Let's suppose we are having one more user over there, okay? That user having IP address on this range 10.1.1.200. And this guy initiate a connection towards the Facebook, okay? This guy initiate the connection towards the Facebook. The packet format is this one, 10.1.1.200, Facebook IP 139.1.1.100. It is also using the same port 1, 2, 3, 4 because this is the another guy, okay? So it can use the same port. This is a chance, right? They maybe these guys they both use the same port, and the destination port which is 80. So this is source IP, this is destination IP, this is source port, and this is destination port. When this traffic reaches to this guy, so it will change the like this. So I will design that packet here, okay? 200.1.1.1 and 139.1.1.10, and port become that 1, 2, 3, 4. What happens in that case? Because both guys are using the same port, right? So what happens in that case? Firewall is not able to identify, right, when the reply coming from this firewall, like this is the traffic coming for this guy or for this guy, right? In that case, ASA also do the port randomization. Port randomization means if user having this port, then ASA basically change this port into some other port, okay? This is the wrong one, like 5421, like this. It also randomize these ports, okay? Maybe here we are using 537, so it will change into like it use anyone like 5,000 or 50,000, anything. So the thing is, I'm trying to explain that kind of scenario as well, right? When both the having, maybe ASA can do the forwarding on the same port as well. It can use the same port, right? But there is a port randomization happens, okay? So ASA chooses that port. It can also change the port number, okay? That port. Maybe it using 63,000. And destination port is always same after data. So that is the actual PAT, okay? How PAT work? It's like working of PAT. Now there's a one more net is remains. So let me also complete that net in 5 minutes. So after that I will stop that class, and tomorrow we will discuss the ACL and net. So tomorrow we will complete the theory and the configuration as well. So what have you know, in DMZ usually we host the servers, right? Let's suppose you are having there 1,000 of servers, okay? Like this is your switch, this is your router, and these are your servers. Server 1, server 2, server 3, okay? And these are your business partners network, okay? This is anyone which is below your business partner. And you are having also server 4. So this is your business partner, or like maybe you know like Facebook is also hosted the same one. So anyone can access the Facebook, right? Anyone can access the Google. So means these are your organization also providing some kind of services, okay? Like some kind of web services, some kind of sales kind of services and all, okay? And these are your business partners, so maybe users. They also need to access these servers, right? But what happens, these servers having the private IP address, like this one having 10.2.2.101, this having 10.2.2.102, this having 10.2.2.103, and this is having 104. Like this, they are having IP address like this. These are the private IP address, okay? So generally what happens, to host these servers, we need a public IP address, right? So generally what happens, if we want to host that 4 server, in that case we need a 4 public IP, because this is your business partner. He cannot able to reach till these servers by using this IP address, right? Because this is a private IP address, and that IP address is no we are not having, like in internet, they are not having any routes for these particular private IP address. Okay, so what happens? In that case, we need a 4 public IP address, and we always configure the static net. I will change my statement regarding these 4 IP address. Okay, we can also do that job by using 1 IP address only. Okay, but I will come on that point little bit later. So for that we usually need a static net, and static net is a bidirectional net. You see in PAT, right? Only inside users can go outside, right? You have not seen any scenario outsiders also coming to your network. Only when your inside users send any traffic, the reply packet comes. Okay, they cannot send the request packets. Okay, in case of PAT, so PAT is a unidirectional. That's why, means we can initiate the traffic from one direction only, from inside to outside. But in a static net, we can initiate the traffic from any direction. Means they can also send any kind of traffic towards these servers, and these server can also send the traffic towards these hosts. This is a bidirectional net. Okay, so they will ask, like in interview, what is the difference between dynamic net and static net? You have to tell that statement. Dynamic net is a one-to-one and unidirectional. Static net is also a one-to-one and bidirectional. Okay, so that's the way how we can. So that is the way how we will usually host our service for publicly, means anyone can also access these servers. Okay, maybe your organization having one website, right? You need to host that website publicly. Okay, for that you need a one public IP address. Okay, after that these outsider users can use this particular IP address to reach your web page of your company or your organization. Okay, so anyone have any doubt on these? Because tomorrow we will see the lab on that. Okay, I will configure everything over there. After that you can see the actual picture. Okay, so anybody having any doubt on that? Guys, okay then, so I'm just stopping the class now. Let me just, I will share that recording tomorrow, and you will get that second day recording maybe